Hello everyone, welcome back. In this lesson, we're going to talk about comparing the difference between two population means by using a confidence interval. This is called a two-sample t-interval. And under certain assumptions and conditions, the sampling distribution model will follow a t-distribution with a certain number of degrees of freedom. Okay, so if we want to find the confidence interval for the difference between two population means, mu1 and mu2, then we will construct the confidence interval using the following method. So we will look at finding the difference between the sample means, so y1 bar minus y2 bar. We will add and subtract a critical value multiplied by the standard error. And the standard error for the difference between the means is given by this square root formula here. Now, the critical value will depend on the level of confidence that we wish to achieve, as well as the number of degrees of freedom. Now, if you recall, the formula for finding the degrees of freedom was rather unpleasant, and so we will use a conservative estimate instead. So we're going to take the smaller of the two sample sizes minus 1. Okay, so the smaller of n1 minus 1 and n2 minus 1. So let's have a look at an example for finding a two-sample t-interval. So let's suppose a psychologist was interested in exploring whether or not male and female college students have different driving behaviors. She opted to focus on the fastest speed ever driven by an individual, and she conducted a random survey of 34 male and 29 female college students, asking them for the fastest speed at which they had ever driven. So here are the results of her survey. For the male drivers, we have a mean speed of 105.5 miles per hour with a standard deviation of 20.1. And for female drivers, we have an average speed of 90.0 miles per hour with a standard deviation of 12.2. So let's construct a 95% confidence interval for the difference in population means. Okay, so the first thing we'll do is check the assumptions and conditions required for the confidence interval. So here we have the independent responses assumption. Okay, so here we're looking at the fastest speed of each driver. And so within each of these groups, the fastest speed of one driver should not affect the fastest speed of other drivers. Okay, and now because we are dealing with two different populations, we have the additional independent groups assumption. Okay, so the groups must be independent of each other. And so what this means is that the fastest speed of a male driver should not affect the fastest speed of a female driver and vice versa. And so the fastest speed of a female driver should not affect the fastest speed of male drivers. So now to check for the independence assumption, we'll look at the randomization condition. So here we're given that the psychologist conducted a random survey. Okay, so we have a random survey, and so this condition is met. Therefore, we can assume independence. Now the next assumption is the normal population. Okay, so the population must be normally distributed. And to check for this condition assumption, we will look for the nearly normal condition. Okay, so the sample distributions should look nearly normal, so unimodal and symmetric, Or, due to the central limit theorem, as long as our sample sizes are large enough, so at least 30, then we can assume that this condition is met. And so let's have a look at the sample sizes. We have 34 male college students and 29 female college students. Okay, so for the male group, our sample sizes are large enough. But for the female group, we have 29, which is not quite 30. And so it may be a good idea to check the histogram for a lack of skewness. Okay, and so these methods do not work well if there are extreme skewness in our data. And so we want to make sure that the distributions are not very skewed. Okay, so now let's have a look at constructing our confidence interval. All right, so we're going to take the difference between the sample means, so y1 bar minus y2 bar. We will then add and subtract a critical value multiplied by the standard error. Okay, so we're given that the average speeds are 105.5 and 90.0. And their standard deviations are 20.1 and 12.2. Okay, so what we need is the critical value, and the critical value will depend on the level of confidence as well as the degrees of freedom. So let's have a look at finding the degrees of freedom. We will take the minimum of n1 minus 1 and n2 minus 1. Okay, so here we have 34 male students and 29 female students. So we want the smaller of 33 or 28. Okay, and so that gives us 28 degrees of freedom. And we want to construct a 95% confidence interval. Okay, so now to find our critical value, we will use our t-table. Okay, so for 95% confidence and 28 degrees of freedom, the critical value is 2.048. Okay, that is for 95% confidence. Okay, so now the next thing that we need is the standard error. And we calculate the standard error by using the square root formula. So we take the standard deviation squared over the sample sizes added together. Okay, so we have the square root of 20.1 squared divided by 34 plus 12.2 squared divided by 29. Oops. And our standard error is going to be approximately 4.1249. And so now we have everything we need to calculate the confidence interval. Okay, so the confidence interval is going to be 105.5 minus 90.0 plus or minus the critical value, which is 2.048, times the standard error, which is 4.1249. All right, so we get 15.5 plus or minus a margin of error, which is 8.4479. And so that gives us our confidence interval, which is 7.05 to 23.95. Okay, and here I'm just rounding to 2 decimals. Okay, so what we can say is that we are 95% confident that the true difference in mean speeds is between 7.05 miles per hour and 23.95 miles per hour. Okay, so what we're given is that the difference between mu1 minus mu2 is somewhere between 7.05 and 20.95. Okay, so mu1 minus mu2 is some value between our confidence interval. And because our confidence interval is entirely positive, this means that mu1 is larger than mu2. Okay, so the difference between mu1 and mu2 is positive, which means mu1 is larger than mu2. Oops. Okay, so this suggests that the male college students drives at a faster speed than female college students.